In the last video, we reviewed some rules of differentiation. In this video, we're going to take a peek at a few applications of the derivative. We'll look at slope, demand, and problems associated with cost. So I'll work problems 11 through 13. Number 11, consider the function f of x. Find the slope of the function at 1. Slope is a code word for instantaneous rate of change, which is also known as the derivative. So when it says find the slope, we're going to find f prime. At 1, we're going to find f prime of 1. So what we need to do first is find the derivative. In this case, we'll call it f prime of x. We're dealing with a polynomial, so we can simply differentiate term by term, applying the power rule each time. So the derivative of our first term, which is x to the fourth, is 4x to the third power, plus the derivative of our second term here, it's going to be 2 times power rule 3x squared. That simplifies to 6x squared. Plus, how about the derivative of x? Have you gotten that one down? It's 1. And the derivative of negative 1, since it's a constant, is 0. So at this point, our derivative is complete. Now we need to evaluate the derivative at 1. So let's find f prime of 1. We're simply replacing all the x's with 1's, and we'll go back and calculate. Feel free to use your calculator, but on this one, since we're dealing with 1's, I think I can handle this one. 4 times 1 to the third power, remember 1 to any power is 1, so we have 4 times 1 plus 6 times 1 plus 1. It looks like our slope in this case is 11. Part B, write the equation of the line tangent to f of x at x equals 1. Anytime we want to write the equation of a line, we're going to use our point-slope form. Please memorize this for your exam. Y minus y1 equals m times x minus x1. So the x1 and y1 are representative of the point of tangency. So we know x1 is given to be 1, but we don't know its corresponding y value. So we are going to have to do a little bit of work here to find out what y1 is. So let's do that first. To get the y1 that corresponds to, we'll call this one x1, we're going to plug it all the way back into the original function. So just kind of on the side here, let's evaluate f of 1. Boy, I'm glad we're calculating with 1's. That makes it easy. Less tendency to make those little calculation mistakes. All right, so evaluating here, those are going to cancel. We have 1 plus 2 or 3. Okay? So when the input, x1 is 1, the output, y1 is 3. The other thing that we need for this formula is the m. M represents slope, and we found that on the previous part to be 11. So now we're ready to plug all this information into our point-slope form. Remember, in point-slope form, the x and the y are the variables. They stay in x and a y. So we have y minus y1. We calculated that to be 3, equals slope m, that's 11, times x minus x1, which is given to be 1. All right, that's great progress. We just need to simplify by isolating y. That way we will express this as a function. So let's go ahead and distribute the 11 on that right side. That gives us 11x minus 11. Let's add 3 to both sides. That's going to give us 11x minus 8. So the equation of our tangent line is 11x minus 8. Remember, you can check this with your calculator. Let me demonstrate that to you very quickly. It can help you to catch some mistakes on your exam. So on your calculator, go to y equals and enter your original function. So x to the fourth plus 2x cubed plus x minus 1. All right, here's a little sneak peek over here of the graph. I can see it's a polynomial that kind of looks like a W. Now, I'm also going to enter the equation that I obtained for the tangent line. That was y equals 11x minus 8. And I want to view both of these together. So I'm going to go ahead and press my graph button. And this is simply a visual check. What I'm testing to see is the equation that I entered for the tangent line actually tangent to the function. So the point we were interested in was the point 1, 3. I'm saying, okay, at this point it's not too bad, but I'd like to see it a little more clearly. So let's zoom in a bit. I'm going to press zoom, my zoom button. Sometimes when I write it kind of messes it up here. Zoom. Number 2, zoom in. And I want to get really close to the point in question, which is x equals 1, y equals 3. See how close I can get to it. I may not be able to get exactly on it, but it'll be pretty close. All right, so x is 1, y is 3 approximately. I'm going to press enter. I'll get a closer look at the point of tangency. I'm just checking to see if my line is in fact tangent. Looks pretty good to me. Now, if you want an even more accurate check, you can do second calculate. All right, calculate is there above my trace button. Notice number 6, dy dx. You should recognize that as the derivative. And by the way, did you spot number 7? I bet you recognize that as well. That's an integral. So we're interested in calculating number 6, the derivative, at x equals 1. So I'm going to type in 1 and press enter. It's going to give me the value of the slope, 11.000006. We got exactly 11. By the way, did you know you're smarter than your calculator? You calculated the slope to be exactly 11, and you are correct. Your calculator uses approximate numerical methods, and so sometimes it does have some error. But this evaluation is enough to give me confidence that my answer is correct. So feel free to use your calculator to support the work that you do, even on your final exam. You can take your calculator into the final exam, but remember, absolutely no cell phones in the testing room. Let's move on to problem 12. Suppose the demand for a certain item is given by D of P, where P represents the price of the item in dollars. So P is price in dollars, and D is demand, number of units demanded. Find the rate of change of demand with respect to price. Remember, rate of change indicates derivative. So this is not a hard problem as long as you know how to interpret that vocabulary. We're looking for d prime of p. So I'm going to look at my demand equation. I'm going to differentiate term by term. So the first term is negative p squared. I'm going to copy down that constant coefficient -1, apply the power rule to that first term to get negative 2p. Derivative of the second term, test yourself. What's the derivative of 8p? Did you get 8? And finally, the derivative of 150 is 0. So that's that. See how easy it is if you know what it's asking. So rate of change of anything is simply first derivative. We are looking at the instantaneous rate of change. Part B, find the rate of change of demand when price is $5. So let's break it down. Find the rate of change of demand, that means derivative, specifically when P is 5. So I'm translating that English into these symbolic forms, and it tells me what to do. Find d prime of 5. So I'm going to go to the derivative I just calculated. I'm going to replace P with 5. And let's see what we end up with here. Looks like we have decreasing demand. Negative 10 plus 8 is negative 2. And what have we calculated here? For every dollar of increase in price, demand drops by 2 units. So negative 2 units per dollar. Remember, demand is measured in units. price is measured in dollars. So the derivative of demand with respect to price, notice we're measuring units on top, dollars on the bottom, if that helps to obtain those units. Okay, problem number 13, let's move on. The total cost in hundreds of dollars to produce X units of a certain product is C of X. So in this case, X is number of units, and C is total cost, and that would be in dollars. Find the average cost for each of the following production levels. All right, so we're looking at average cost. Now, average cost we denote as C bar. So if I'm looking for an unknown number of units, X, this is going to turn out to be a function of X. So I'm going to take the total cost and divide by number of units. That's very easy to remember. If you need to calculate your average grades, what do? You total your grades, you add them all up, and then you divide by the number of grades, right? That's all I'm doing here. I'm taking total cost divided by number of units. Now, my cost function is a rational function. So it might be easier to see this as 1 over x times c of x. Those two expressions are equivalent, but that allows me to manipulate the expression a bit easier. Okay, so I'm going to replace my cost function with the given rational function. And really, you don't have to do anything to this other than just glue it all together. If you want to go ahead and multiply out the denominator, call it 2x squared minus x, that's a-okay too. What just happened there? I distributed the x in the denominator. So there's my average cost function. Next, it's asking average cost for producing 20 units. Well, all I have to do is plug x equals 20 into the function that I just found. 20 plus 1 over 2 times 20 squared minus 20. Let's calculate. The numerator gives us 21. In the denominator, we have 20 squared, which is 20 squared is 400. 400 times 2 is 800. And then 800 minus 20 is what? 780. So 21 divided by 780. And that was dollars. You could certainly approximate that. Whoops. Get out of here real quick. 21 divided by 780. And then remember, this was in hundreds of dollars. So if you wanted to approximate it, 269, that would be a-okay. And this is per unit. All right, finally, find the marginal average cost function. The marginal average cost function. Marginal means derivative. Hold on just a minute. I'm spotting one thing. Did you spot it? If you want to reduce that 21 over 780, math fraction, 7 over 260. Let me go ahead and reduce that 21 over 780 to the 7 over 260. Don't want to give you an unreduced answer. Got to be a good example here. All right, let's move on. Next, find the marginal average cost function. Marginal is another code word for derivative. Slope, instantaneous rate of change, marginal. All of those are a signal to you that you should differentiate. Notice it says marginal average cost. So I'm going to have to find the derivative of the average cost function that I found in part A. What if it had asked the marginal cost? Well, then I just find the derivative of the original total cost function given in the problem. Okay, so make sure you read very carefully on your final exam. So let's find the derivative of our average cost function. We need to find C bar prime of x. So I'm looking at my answer on 13a. I observe that it's a quotient. So to get the derivative, I'm going to have to apply the quotient rule. So take the denominator and square it first. Lead with that term in the numerator. And then multiply by the derivative of the numerator. Did you catch that? The numerator is x plus 1. Its derivative is 1. Be very careful on your quotient rule. Make sure you subtract your two terms. Can you anticipate what comes next? This will be the derivative of the denominator. The denominator is 2x squared minus x. Its derivative then is 4x minus 1. And then I have one more thing to complete my quotient rule. Do you know what it is? The numerator in its original form. Okay? So you have same times derivative minus derivative times same. Finally, we need to simplify. Remember, if you make it that far, you get credit for the calculus. Full credit comes from the algebraic simplification. So working on this numerator, we have 2x squared minus x times 1, which is just 2x squared minus x. Then we're going to subtract the product of these two binomials. Be really careful here. When you FOIL those two binomials, make sure you get the result in parentheses. That's going to indicate that I need to distribute this negative sign. Okay, so FOILing these two binomials, 4x times x gives me 4x squared. The outside terms are 4x, the inside terms minus 1x. Those combine to give me a net middle term of plus 3x. And the last terms, negative 1 times 1 is 1. Leave your denominator factored, always. It's going to make it easier to reduce later on if necessary. Okay, now that we have those red parentheses there, we can break them up by distributing this negative into those parentheses to obtain 2x squared minus x minus 4x squared minus 3x plus 1, all divided by 2x squared minus x quantity squared. Okay, finish up by combining like terms. We have 2x squared minus 4x squared. We'll go ahead and express our answer here. That gives me negative 2x squared. We have negative x minus 3x. That combines to give us negative 4x. And then last term there is 1 divided by denominator squared. All right, so average cost is total cost divided by x. Marginal average cost is the derivative of your average cost function. One more question. What's marginal cost? Marginal cost is the derivative of your original cost function. All right, I hope this is helpful. You're making progress in your study, so hang in there.